go there and then do the same things with your own hands. Okay?
Yes.
First of all, let me ask you about your assignments. It was not done. Okay. Anyone else? Okay. And what about the software? That was Microsoft 365 and chemical composition calculator. I think it was already shared with one of the colleagues who was here. With him? With you, I think. If you got it from my PC?
Yes, I do.
Okay, if anyone who needs those software, those are available on my PC, on my laptop. And it is passwordless and it is open now. My laptop is in MRL. You can access it and you can take those software in USB. Okay? There is Microsoft 365 and chemical composition calculator. Okay, so is the base composition process of barium titanate was already discussed, and that was your assignment to do the same calculation on paper and then on the software and then compare them in terms of percent errors. But I think you didn't complete your assignment, so you know that this is a very important dielectric material, and it is composed of two basic elements. That is barium and another one is titanium. So from where does those elements, we can get those elements from their oxides. Okay? From barium oxide and from titanium oxide. Because they are naturally available. So, what is the next step? Actually, if I wish to synthesize 1 gram of barium titanate, so the question is, how much do I need barium oxide and titanium oxide? Okay, now we are going to calculate those amounts. So, you know that this state is stable. You know this is a stable state. How it is stable? So what is the charge on this oxygen? -2. If you don't know, you can derive it from here. Because if this is -2, then 2 into 2, this should be +4. So this should be +4. And how much should be this? Should be +2 because this is -2. Okay? So first of all, whenever you decide to synthesize something like barium titanate or any other oxide, first see that is the state stable or not. If the state is stable, then you can proceed further. Okay, so this is a stable state almost, because +2, +4 and 3 into -2, so +6 and -6. This is okay. Okay, then after getting these, we have to derive that the molar mass or atomic mass. So what is the molar mass of oxygen or atomic mass of 16 AU or 16 moles of oxygen in 1 gram. Okay. So this is 16 moles per gram. And what about the barium? How much is it? It is, I think,
137.
127.
137.
137. 37 moles per gram. This method is very simple, but little bit confusing. Okay, so before going into this method, just understood the basic logic. So for example, let me give you an example. For example, I am going to prepare a 10 gram of rice. So for a 10 gram of rice, if the desired amount of salt for 1 gram of rice is, let's say, 0.1 gram. So how much salt should be required for 10 gram? How much? That is the question. If for 10 gram the requirement is 0.1 gram. So how much for 100 grams? Just multiply this by 10 and this by 10.
Yes.
Okay, you can do in this way as well. But another way, 0.1 is how much percent of 10? This is another way. This is almost 1%.
Yes.
Okay? So for 100, what should be the 1% of 100? 1% of 100 is 1. So one can do in this way. Okay? The same thing is here. Same thing is here. It's okay. This is. So first, after calculating is the molar masses. Molar mass of this oxide, because those are our ingredients. Those are our onions, chilies, garlic, while cooking some kind of dish. Okay. And for this one, what should be the molar mass of titanium?
47.
47. Let's say 47. And this should be 47 mole per gram. And how much?
Plus 32.
32 moles per gram. Okay.
Yes, sir.
Now simply add this, and you will get what?
143.
Here you will get 153.
Yes.
153 moles per gram, and here you will get
79.
79 moles per gram. But your requirement is this one, and you are going to get this one from those two. Okay? So now calculate the molar mass of the barium titanium. This should be like BaTiO3. So O16 into 3 and Ti 47 and Ba 137. So 233 moles per gram. Now, as it was already discussed here, that if I need to prepare 100 gram of rice, and the basic requirement is for 1 gram I need 0.1 gram. So there are two ways to calculate the amount of salt for 100 grams. One way is just by multiplying both sides by 10. Okay, and another way, that let's see that 0.1 is 1% of 10 gram. Then for 100 gram, what should be the 1% of 100? 1. So the requirement is 1 gram. So just like that, I need this much. So how much should I add this? And how much should I add this? But you know, those materials are not available in this form. We can scale the materials in grams only. Okay? So if we see how much percent is contributing this one in this amount, how much percent is contributing this one in that much amount. Calculate it just. Find out that this amount is how much percent of this. 153 divided by this into 100. So I think it is around about 63 or 65%. Do it on your cell phones and then calculate it. Do you understand?
65.6.
Huh?
65.6.
What is the ticket value up to Yemen from here, from Pakistan to Yemen? How much it costs?
2 years, 3 years,
No, money. How much does it cost?
people who are
The 232
give
Razi,
me money 1 year, after 1 year, give me.
the 232 Razi.
No, I was not asking.
Sir,
I'm
232.
asking that
And
how
people,
much amount you need to go by air from here, from Pakistan to Yemen? How much air ticket price?
है ना?
price and pay
Yes.
$600 in month.
600 that how much percent?
Sir, the 232 is 65.9.
Sangha?
232.
232. And how much it is?
65.9.
65.6. 9%, let's say.
65.9.
And how much? What is it? And this is almost, let's say, 34 point. 33 point? बस ठीक है कोई उसी तरह let's say this is 29 sorry 31
Yes, sir.
ठीक है
Yes, sir.
इस तरह ठीक है
ठीक.
is it okay? So in this much moles per gram barium oxide is contributed. What is the contribution of barium oxide? Is 65.6%. And in this much moles per gram of barium titanate, the contribution of titanium dioxide is 34.31%. Now, your requirement is to calculate for 1 gram, or your required quantity is just 1 gram. You are interested in to synthesize
1 gram.
1 gram of barium titanate in the body. So for 1 gram, how much does you need? How much grams of barium oxide and how much grams of titanium dioxide? You are going to derive this. Okay. So if for this is 65% and for this is 34%. So for 1 gram, so what is the 65.69% of 1 gram? That is 0.6569 grams. And what is this? This is barium oxide. Okay?
Yes.
And for 1 gram,
0.34.
this is 0.3431 grams. Okay? And what is this?
Titanium dioxide.
Titanium dioxide. Okay? So far, to synthesize 1 gram of barium titanate, one will need this much grams of barium oxide and this much grams of titanium oxide. Do you understand?
Yes, yes.
It is very easy. For example, if my requirement is, let's say this is 10 grams, then just multiply this figure by 10 and this by 10.
Yes.
If my requirement is, let's say 33 grams, then multiply this side by 33 and this side by 33.
Yes.
It is very easy. Do you understand?
Yes.
Just if you know how to derive the percent of anything, you are breaking this, you can learn this technique very easily. Okay, आप लोगों को समझ आ गई? ये बहुत आसान है, वैसे कॉम्प्लिकेटेड लगता है ना? Either you can do the same through a calculator. Okay, but before going into the advanced technology, understand those things at least for once. Then use the technology like calculators and AI tools and like this. Okay. So this process is very easy, but after getting those two powders, now it is calculated that we need this amount of titanium and this amount of barium oxide to synthesize this amount of barium titanium. But what after that? It is not finished here. So you are going to mix it, to powder it, to crush it properly. So the first step is, this is the page composition process. This is step number 1. Okay? Calculation of batches. Okay, this is step number 1. The step number 2 is, and milling. Milling किसे क्या होता है? ठीक है, grinding and milling. Grinding नहीं है, grinding है. ठीक है, तो grinding and milling. And what is the purpose of grinding and milling? And that is to mix both or so many batches together to get a uniform cytometric. ठीक है. And the reason behind this, if the powder and powder form, if the materials are very near to each other, for example, if barium is very near to titanium, then they can, this should be easy to form a phase like barium titanate. Otherwise, if barium is here and titanium is here, then it is not easy to combine them because a lot of energy and a lot of effort will be required. So for that purpose, what we are doing, we mix them and grind them properly and for a very long period of time. Okay, so what is the grinding and milling process? It is composed of I will show you this practically after a few minutes in MRS. Okay, here we have a grinding or milling machine, and there we have a jar. Okay, this is the jar which is filled of grinding media, small balls. Okay, and those small balls are made up of zirconia. Because zirconia is chemically stable and it is very hard material. Okay, and inside that jar there is your barium oxide plus titanium oxide, required amounts of grams inside that jar, and it is almost 1/4 or half filled. Okay, 1/4 or 1 by 2 filled from that media, and a liquid like acetone, propanol, any volatile liquid. Okay?
Yes.
For example, methanol, ethanol, propanol, isopropanol are cold type. So when it rotates, what should it do? The bars come closer together and they crush this barium oxide and titanium oxide into further small pieces. After 1 or 2 or 3 hours, at the end you will get some uniform solution in which each particle of barium oxide and each particle of titanium oxide are very close, are very near to each other. Okay? And they are in almost uniform particle size. Okay? समझ आ गया? I will show you this practically. Step number 3. After that, drying, because this is a mixture. Okay, just pour this mixture in a beaker. Wash the zirconia ball in a mesh. Okay, those are steps which are not discussed here. We are going to the step number 3. But before going into the step number 3, you have to wash this media with some same kind of liquid. For example, if you are using acetone here, then wash those balls with acetone. Get the solution in a beaker and put that beaker in a drying oven on 90 degrees C or 80 degrees C for overnight or for 12 hours, because after that you will get a powder which is free of moisture, which do not create beads, which is almost uniform. Okay. So here a drying oven. Now put this, wash, and then put this in a beaker inside the oven. Okay, for drying. समझ आ गई? Then after that, step number 4. Step number 4 is to sieve. From here you will get some powder which is like this. Some big particles, condensed particles, some small particles. So you will need some uniform powder. So took this non-uniform mixture to a sieve. You know the sieve? Chart?
Yes.
Chart? Chart, you know what is chart? For example, let's see, this is a mesh size of 200 microns. Mesh means ये इसके अंदर जो सुराख है वो pore size. ठीक है, and this is already defined over the net. So how much is 200 micron, how much is 600 micron, and how much is 400 micron. And after sieving this powder, you will get here a uniform powder. Okay? Because the uniform powder is required for further processing. If the powder is not uniform, if some cooking material is not properly mixed with a big spoon, so your end product will be not good. Okay, just like cooking, same is the process here. In cooking, few steps are different, but here are some different steps, because in cooking we are dealing with some vegetables or meat, but here we are dealing with wet material. Okay. Then step number 5. What did you think? What should be the step number 5?
Century.
If meat is washed well, tomatoes are chopped, onions are chopped, the oil is ready, then the next step should be to put all these things together in a crucible over the fire for cooking. Okay? तो उसको हांडी के ऊपर रखे ताकि वो पक जाए. So the next step is calcination. What is the calcination? This is the required temperature for a material which transform that material to another kind of way. Because here you have just a mixture of barium oxide and titanium oxide. This is not a barium titanium. Okay? After calcination you will get a barium titanium phase. Okay? So after that, but how did you know that this is the required calcination temperature? Okay? That is from DGA and DTA analysis. Thermogravimetric analysis and differential thermal analysis. Okay? Those techniques, combined techniques, are used to derive the suitable calcination temperature. For example, those two techniques will tell you about the exchange or the exhaust of something from a given mass. For example, in first step, your material will lose some amount of weight in grams because few water or water vapor is absorbed. So in the first step, dehydration, in the next step, dehydroxylation, then melting, okay, and then some phase transformation, and after that boil, step by step. In each step, something is going out from your ingredient and something is going inside in your ingredient. So in parallel, what is happening? Exothermic and endothermic exchange of energy. So combining these two plots, one can know the required calcination temperature for his bed. Okay, if your phase is almost unknown, for example, you derive that you are going to synthesize some new kind of material and you don't know what is the calcination temperature because it is not given in literature, for example, then took it to the TGA process, and from here you will pick the required calcination temperature. Okay, and for polymers, there is no phase transformation, it is something like oxidation and reduction taking place here and carbonization. Okay, so for polymers we derive those things, and for solid oxide material we are most interested in calcination temperature. When your material is calcined, that means step number 6. Step number 6 includes characterization, the basic characterization. Either your material is perfectly prepared or not. After cooking, you have to serve your dish to someone and then ask him that it is good, excellent or not. Okay, so this is the judgment technique, that it is a barium titanate or something else. If it is barium titanate and there is no defects in your structure, so it is almost okay and you can exceed further. Okay, here this is the basic characterization. There are so many other which is also required sometimes, but the basic one is the X-ray diffraction. step number 7, you need to design a device. So for basically for dielectric materials, we design pellets. The device is in the form of pellets, like tablets or paracetamol. Because those are the dielectric materials, and one can analyze the dielectric properties if the material is transformed into some kind of capacitor structure. And what is a capacitor? A dielectric material sandwiched in between the two plates. So before that, you going to fabricate the device, which is like a pillar. You have to press this powder. This powder is now barium titanate, not a mixture of barium oxide and titanium oxide. Okay? In a pellet presser.
Yes, sir.
This step is performed in a furnace. This step is performed in a, the drying one is in oven, and this one is in furnace. Okay? So here, press the powder in pellet presser, and at the end you will get some kind of tablets. But those tablets, when you see, those tablets are not properly adhesive to each other. It is still very low mechanical strength.
Yes, sir.
It can be easily broken.
Yes, sir.
So for that purpose, what you will need to center that pellet. Centering, that they become harder. So what is the required centering temperature? This is 100 or 150 degree above the calcination room temperature is your centering temperature. Okay? Is it easy? After centering, here is the step number 4, 8. Just coat this center pellet with a conductive material on the both sides. Usually we use silver paste. Just like coloring your nail, the same is the method
Yes, sir.
to coat the silver over on the both sides of that pellet. Okay, it is also very simple. And after that, you can characterize your device for dielectric or electrical properties. Okay? Easy, no? So here again, what is for preparing some kind of dish, you need some ingredients from the market. Here you are going to prepare this dish, which is barium titanate, and the ingredients are barium oxide and titanium oxide. Okay? So the first step is to, for example, if your requirement is to cook only one chicken, and here your requirement is to prepare only 1 gram. So for one chicken, how much tomatoes do you need? There should be some standard which is also available on the chefs cooking website on their website. For example, for 1 kg of chicken, you need, for example, 10% of tomatoes of the net amount. So what is the 10% of 1 kg? It is 100 grams. Okay. Similarly here, for 1 gram of barium titanate, how much one need barium oxide and how much titanium oxide? So calculate that the total is this much grams per mole. Okay, sorry. Okay, this is here. This is not like this. This is, I think this is grams per mole. Okay, like this.
Yes, sir.
This is not 100%. Okay, so this is this much per mole. So what is, how much percent is the contribution of this one in that much amount? That is just by calculating, this is that much percent and this is that much percent. So, for example, let's say this is 67 and this is almost 33. So what is the 67% of 1 gram? That is 0.67. And what is the 33% of 1 gram? That is 0.33. If your requirement is other than 1 gram, this is also very, just multiply that by both sides by that amount. Then the steps, grinding and milling, selection of media, widely zirconia balls are recommended, tungsten is also used. Okay, and different types of solutions, mostly alcohols, ethanol, propylene or DMF, like that. And then put that jar, half filled or 1/4 filled, over the rotating ball mill, that is called ball mill. Okay, and after 10 hours, 20 hours, you will get a uniform mixture. Then took the uniform mixture, wash this media, because some of your powder is stuck with the media, with the wall of the media. So wash it gently and then took the whole solution, your whole solution, into what? Into an oven, and you will get some kind of powder with big or small beads. Then the step number 4 is sieving. Sieve this powder with your required mesh size. Try to achieve the minimum should be the particle size. The excellent should be the reaction. Okay. So after sieving, calcine this powder, put this powder in some sort of crucible, usually alumina, porcelain and different types of materials are recommended to process your material. Mostly we recommend the alumina because it is stable up to 1100, 1200, this kind of crucible. They are chemically stable. Always use the clean crucibles. Okay? Clean crucible, the clean one. Sometimes the porcelain crucibles are also recommended because they are cost effective. But the one which were available in Khaybar Bazaar, they are not so good because they are already glazed with the borax. You know the shining stuff or those crucible or tea mugs or tea mug is just like a glass of shiny stuff. That is called borax. This is the borax glazing. So if your composition contain some electropositive and electronegative atoms, so there should be some sort of probability that they can react or interact with them. So it is better to use a virgin alumina crucible instead of porcelain type glazed crucible. Okay. They are little bit expensive, but if your research is very precious, then use this one. If it is not precious, then you can use it.
Yes.
But several other types. What is the material of this zirconia? You can use the zirconia crucible. Even one can use the quartz crucible. But the most stable and the most efficient one is the platinum crucible. Because sometimes our material react and after this step one will get some kind of a sticky material which stuck with the walls of the crucible. mostly in processing of glass. Because the glass is very aggressive, it can adhere with so many materials. Only it do not stuck with platinum or gold or alloy. Okay, but this is very expensive. But that depends on your research. If your research is very high profile, then you have to use such kind of crucible. If your research is normal, not very impactful research, then you can use like porcelain like this. After calcination, how can one know the calcination temperature from TG and DTA? Okay. The next step is
XRD.
after calcination, took your calcine powder for X-ray diffraction, and there you will see is the required phase is achieved or not. If it is achieved, proceed further. And at the end, you will get the device in this way and took this device for characterization. So this is the basic steps of base composition process. Okay, now come to the material research about